So we're here today to talk about full stack machine learning and generative AI for all of you and us, data scientists and machine learning engineers. Part of the intention here is, I've worked in education for a long time in the data science, machine learning, and AI space, and there still are certain impedance mismatches between what we teach and what happens in practice in a business and enterprise industrial setting for data science. So we're going to try to move towards what it looks like to do production machine learning and generative AI today. So essentially thinking about how we build software systems and ML systems that incorporate data and AI. Okay. So to that end, let's jump in. And the first thing I want to talk about is full stack machine learning. And then we're going to jump in and do a bunch of coding together. Then we're going to talk about generative AI. And then we're going to jump in and do a bunch of coding together. So what are we talking about when we're talking about full stack machine learning? We're talking about an engineering discipline and how to engineer systems powered by machine learning, okay? Such as self-driving cars, targeted advertising, fraud detection, lead scoring, the whole gamut of the types of things we talk about and build, okay? So the question is, what type of thing are we building? Are we building cathedrals where we decide and plan a specific deliverable and where we have to allocate a large amount of time and resources and perhaps prepare to spend a long time building it, okay? Now, the results can be incredible here, but they're fundamentally static and hard to change, and you can't afford to build too many of these. And as we know, with data-powered software, it can't be static and it can't be hard to change. And we need to be able to afford to build lots of them in the name of experimentation, right? Because we're building a scientific discipline, among other things, right? So on the other side, maybe we want to start building a bazaar where we invite people to share their best ideas and work together as a loose collective. So there's not high initial investment here, super easy to get started, quick to experiment with ideas and react to changing demands. So all of these things sound good, but the results can be limited due to lack of coordinated and goal-oriented investment and lack of shared infrastructure. It's also hard to maintain results in the long term. So we kind of want something between a bazaar and a cathedral, right? And what would that look like? So one way to think about it is we want to start building more farm-like things where we have kind of a collective, with shared infrastructure and shared tooling, but people are able to do things on their own terms as well. So you're able to plan ahead, but also react to results, and you can grow investment as needed, iterate on best results, and it's this that will produce long-term value, okay? So why a farm? Well, several reasons. First, we want to have a culture of experimentation. So we want all data scientists and ML engineers to be able to test a lot of ideas for the applications they're building. And we also want to be able to, nurture all the experiments enough so that we see actual value or not. And a lot of the time we hear, 80% of models or whatever the number is don't make it to production. As though that's a bad thing. And I don't think necessarily without more context we can say if that's a bad thing or not. What I can say is it's a good thing if a non-trivial amount, a not insignificant number of experiments don't make it to production, right? Because this is an experimental discipline. Think about science. Science, I've always said that we need more journals of negative results, right? Science is a discipline that's built on negative and positive results, ideally true negatives and true positives, right? We know that isn't the case now, unfortunately. But the point being is that we should be generating negative results when doing experimentation. But then we can double down on the ideas that work, okay? So what do we need to do this? One thing we need across an organization or any group of people we're trying to coordinate or we want coordinated, quote unquote, rowing in the same direction is common tooling and infrastructure. Python, right? PyData, open source. That's why we're here today, right? And these things, having common tooling and infrastructure saves time and effort and makes it easier to collaborate. So we'll be talking about an open source framework today. A lot of the ideas will be generalizable to other frameworks. We'll be talking about an open source framework today called Metaflow, which was open sourced in 2019 and by Eddie and my colleagues when they ran machine learning infrastructure at Netflix. They built it in 2017, open source in 2019, and has been adopted by hundreds of companies across many verticals now. So we'll be talking about Metaflow today. And the idea is that Metaflow is something that you can use to apply machine learning to a lot of different use cases to create machine learning apps easily. To run, these apps reliably, you need infrastructure, right? So this is something that platform engineers can build, such as robust access to Kubernetes clusters or deployment frameworks or these types of things, or scheduled orchestrators, right? These types of things. And we'll get into the nitty gritty of that, but this is at a high level, what we're talking about here, okay? So yeah, here's a handful of companies such as 23andMe and Zillow and Carter and Realtor.com and Zipline that use Metaflow for just a bit of social proof if you haven't heard of Metaflow before. So I want to dive a bit more into what the full stack looks like, and then we're going to jump in and start coding, okay? Now, a question that I think is worth asking is, once we move to software powered by data, machine learning, and AI, does the software stack necessarily change? I think the default answer should be no, or we don't know. I think the burden of proof rests on me, for example, to convince you that you need other tools, right? So in the spirit of this, let's think about what we want traditional software to do, and then let's think about what happens when we introduce machine learning, AI, and data into the system. Okay, so you can slice your needs and requirements of traditional software in a lot of different ways. If I were to rank order what I want traditional software to do, I think two of the most important things are we want it to run reliably without human supervision. So when I close my laptop, I can walk away and go and have dinner and be convinced that it's still running. We also want it to produce correct results, whoever our end user and stakeholders are. We want to make sure that it isn't making mistakes for them, okay? So these are two of the most important things we require of traditional software. So what happens to these requirements when we introduce machine learning, data, and AI into software, right? So look, we have new things. We have data, right? We have machine learning models introduced into the system, and we even have a new person next to the data engineer, platform engineer, or infrastructure engineer, or software engineer, the data scientist, right? Who has a new and diverse set of skills, right? Which may not be the same, which definitely aren't the same skills as the software engineer. I mean, I come from a research background, right? So let's now think about how this changes what we require for the system. So these systems are built around data, models, and code, right? So how do these different parts of the system interact? So for us to use data for our models, we require some sort of compute. That can happen locally on my local workstation, for example, my laptop. Or if I'm doing significant compute, maybe I'm using a Kubernetes cluster or something online or something in the cloud. Sorry. Okay. So we definitely require data, compute, and models, of course. Now, how do models and code connect? Starting off, maybe you can do this stuff in a notebook, and a lot of the time you will want to prototype the types of models you're building in a notebook. But once models become even slightly sophisticated, you're going to want something more robust, and you're going to want to build graphs of models where you have feature engineering and building different models and hyperparameter optimization, all of these types of things. And you may have seen directed acyclic graphs in data engineering or in machine learning or orchestration. But essentially, these are the types of things that we'll get to that you'll want to build once you have slightly more complex models, right? So we require orchestration. Now, the other thing is, these systems are built by humans. And these humans, such as myself and Eddie, and most of you here, I presume, will be doing rapid prototyping and building lots of models, right? So you'll require versioning. And now, we all know about versioning of code. We've all used, tools such as GitHub, for example. But now we want to be versioning data as well in some ways, and versioning models and these types of things. So the versioning story expands here. And what I mean by that is, so for example, let's say you've got a machine learning model that does something wrong downstream. It produces a prediction which like messes something up. Let's say you've got a fraud detection model and it incorrectly classifies something as fraud, or perhaps worse, does not classify something that was fraudulent as fraud, and your company loses everything, goes bankrupt, shareholders unhappy, you lose your job. That's one of the catastrophic situations. No, let's not go that far. But let's say it does an incorrect classification, because I was going to say in that case it doesn't really matter. Right? You're not going to go back and try to find the model that did it because you don't have a job. But in the case that there was an incorrect classification and you still have your job, you're going to want to see which model created that and which run of the model. So you want to have your models version and your data version, see what day it happened and what was the data set that your model was actually trained on, right? So the versioning story is critical here. Now, the final part of the story is deployment, to connect all of this to the valuable system. Now, this may be, your classic REST API, your endpoint you've set up with an application layer built on top, or it may be batch inference done daily that updates a database. Or it may be, deployed via a slide deck that's created once a week for an executive to consume, or an email that's sent to the entire team. These types of things, right? So the deployment story can take a lot of different flavors. Let's say it's not just an endpoint, which is the most common story. So what we see now is that the ML infrastructure stack starts with data and then goes up now through compute, orchestration, versioning, deployment, and modeling on top, which are all our favorite scikit-learns and XGBoosts and PyTorches. And the truth of the matter is that data scientists such as us really fundamentally want to focus on the top of the stack. Yet there's a huge amount of infrastructure that's required for the bottom, okay? And I just want to be careful. A lot of people say, wait, don't data scientists care about the data? And my response is, of course they do. And what we're really talking about here is that this is really the data engineering layer that makes it consumable for data scientists. So data scientists may not necessarily care whether it's coming from Snowflake or Parquet shards on S3, right? But the data scientist cares about, what the data actually is, as opposed to how it's engineered or what form it's in, right? Now, as we'll get into, Metaflow code, as a lot of other frameworks do, looks like this. It's object-oriented programming. So we're gonna define classes, and we're gonna have each step in the DAG as a different step using the @step decorator here. So let's just have a quick look at this code, and then we're going to jump in and start executing code together. So at the very top, we have the modeling layer. So I'm specifying, and this is actually, part of the dependency management story, which we'll get into, but I'm specifying at entire flow level. So these are steps. The entire thing is a flow. What packages I want, okay? In terms of deployment, I'm specifying here that I want this thing to execute daily, essentially. I can also schedule it so that it updates or runs whenever data is updated in an S3 bucket, for example, or whenever another flow finishes. So were this an inference or prediction flow, I could have it be triggered by a training flow. And we'll see examples of that today as well. The versioning story, if I want variables to persist throughout a flow and also to be versioned, aka stored in some metadata service, I assign it to an instance variable, self.x. And just note that we have two steps here. We have a start step and an end step, and passing self.end to self.next in start tells me that after start, the next step is the end step, okay? The orchestration story, this entire thing is the orchestration. This is how we write the graph of the flow in Metaflow. And perhaps, I wonder how we can do this. I'm just wondering how many people have actually used orchestrators before. Do you know a way we can ask This
Yeah,
is,
there's a polling feature, Hugo. Do you see the 3 vertical bars
yeah,
icon?
great. While
Yeah,
I'm
we can get it up
talking,
on the screen.
do you think you could add a question? How many people have used orchestrators before? Or,
Hmm.
I'd appreciate
I
that.
think it might take over the screen, just FYI. But yeah, let me go
Oh,
ahead.
amazing. Well, with great power, comes, everything. Now, this is one of my favorite things about Metaflow is the ability to, let's say I've got like a big parallel training step that I want to that I need to send to cloud infrastructure. I can merely use the at Kubernetes decorator here and specify how much memory I want. Of course, this needs to be provisioned for me. We're provisioning everything today. Needs to be provisioned for me otherwise by a platform or infrastructure engineer. But what it means is, as a data scientist or machine learning engineer, I don't have to be configuring clusters and writing YAML and all of these types of things in order to start moving from prototype to production. So I can run this locally, and then I can just throw that decorator on top in order to send steps to the cloud. So it really times the loop between prototype and production, as we'll see. And similarly, there are lots of ways to work with data. So where this is a toy example where we're incrementing our instance variable self.x by 1 here. But the data story here is you can access, this is interoperable with all of your snowflakes and S3s and whatever else it may be. Fantastic. Thanks for setting this up, Eddie. I'm answering myself as well. It's cool. So I can see, I can't see the sample size yet, but I can see, it's a new concept to a bunch of you. So we'll go through exactly what this looks like in a minute, okay? So we're about to jump in and start coding. What I do want to say, as I just referenced, is we're going to, be doing a lot of things to be moving between prototype and production. And this isn't a binary thing, okay? It isn't like you deploy something on a REST API and suddenly you're in production and woohoo, that isn't the way things work. The graduated approach really is perhaps, you're sending things to a cloud workstation, then you're coming back and exploring with notebooks, then you're creating workflows, and you're starting to version things, and you're scaling things vertically and horizontally. Then you need rapid data access. Then you start to schedule execution. Then you start freezing your dependencies to make sure it's robust. And then it's like, no, I need visualization. I need to be able to report on my models. Then I need to start thinking about A/B testing, and then you might think then you're at production, but of course then you need to debug and go back to prototyping, right? So I want us to take a more kind of nuanced and holistic view as to what moving to production looks like. It's this entire process. And it may involve just, adding this Kubernetes decorator to access a cloud workstation as part of going to production. Then once you've got some results there, removing it, going back, working locally, right? So this is to debug certain things, okay? Then you want to freeze dependencies so that your cloud workstation has the same packages that you have locally, right? So without further ado, let's jump into the sandbox. Oh, this is interesting. It looks like my tab is not. I need to share my screen again. It's only sharing one tab. And I appreciate that we've taken around 20 minutes and we haven't done any coding yet. But that was all in the spirit of setting it up so we know exactly what we're doing. Okay, so you can see Sandbox now, Eddie.
Looks good.
Great. And I'm looking at the poll. So it does look, pretty much 50-50 actually. For more people, it's a new concept. What's the sample size? I can't see. Can you?
Yeah, we're at about 20 votes. So
Okay, cool.
insignificant, but not nothing. It's 50-50. Yeah.
And can you actually see how many people are in the session by any chance?
Oh, now we got more votes coming in. Okay, I can't give you an exact count. I'd estimate about 80, maybe 70
Amazing.
or 80. Looking at the yeah.
Well, thank you all for being here. It's a true pleasure to be teaching so many interested and excited people who, I mean, are mostly doing this out of their own work time as well. So anyway, what I want to do is to jump into the sandbox. So to be clear, I've just shown you a bunch of infrastructure you need to kind of get started with full stack machine learning. And the question is, how on earth can we just open a Colab notebook and have access to this infrastructure? And the answer is definitively no. So what we've done is we've built a sandbox that in which we can provision everything for you to get up and running with this stuff. Okay. So what I want you to do is to click on the sandbox link, and you can log in with Gmail or GitHub. It's totally up to you. And if you want to hear more about sandbox stuff and news, feel free to leave this thing clicked down here. But if you unclick it, you'll never hear from us. So I just want to make clear that our intention is not to spam you at all or anything along those lines. Okay. So and Eddie, would you mind actually creating one more poll of like, did you get into the sandbox successfully? And so here we have our data scientists accessing data. This is a little story that we're telling here to get you ready for the sandbox. Data and orchestration and having these two things connected, and then versioning. You're requiring all these things, compute and deployment, right? So we need all these things connected. And this is what we're providing for you here. So essentially, you can think of it as Google Colab for the full stack of machine learning infrastructure. Another way to think about it is that it's a superpowered VS Code, right? So if you've used Visual Studio Code before, which is a really cool way. I mean, I'm not sponsored by Microsoft in any way, nor do I think I can't even see a not so distant future in which I am sponsored by Microsoft. But anyway, I'm a big fan of VS Code for developing code and ML systems. So we've built this in the browser, which essentially what we see is our regular scripts here, our terminal here. We've got our local file system here. We have another little thing here, which is a table of contents. And then for each exercise, we have some notes here. Okay. The other thing is, for some reason, these icons should say things, but they don't currently. Eddie, is there a way I can? Do you know what?
Yeah, Hugo, I just sent you a link. You're on an old sandbox version right now. I just sent
okay.
you a link in the chat.
Great. In which chat?
The second icon, if you look on the panel on the right side of your screen,
got it.
There's this second icon
Sorry,
down.
I was looking in our Slack. Great. Thanks so much, man. Thank you all for bearing with us. Fantastic. Okay, cool. So I just want to make sure, I'm just going to go back to the poll, and yes, I am able to access the sandbox. Great. For those who say no, if you want to pop, if you actually can't do it, pop in the general chat. Eddie will do his best to help out. Don't DM him, because the intention is that other people may be able to help as well. So without further ado, though, I'm going to jump in, and we want to start writing or executing these flows. Okay. So we've seen what a flow looks like. As a first flow, what I'm going to do is create one which has a start step, an eat step, because I'm hungry, and an end step. Always good to give workshops when you're slightly hungry, not too hungry, but definitely not full. Okay. Now, Metaflow doesn't put a lot of constraints around how you write your flows, We do want you to start with a start step and end with an end step and do pretty much anything in the middle. The one other thing we kind of require is that if you branch, and we'll see what branching is, to do things in parallel, that then you join them back together, right? And then wrap up with an end step. So how do we run these flows? So you can click run, but what this actually does is, I'm just going to have a look at in here. Essentially what this does is, all you need to do to run code is write Python, then the name of the flow, and this is in, so the directory this is in is hello, and it's flow.py. So I do Python, path to flow and name of flow, and then run. I did some weird indent there. Okay, let's try this again. Okay, cool. So we're seeing some output. Pylint has just checked our code. Then we're creating a local data store, which is where all our metadata will be stored. Then the workflow is starting, and we'll look at the UI in a second. Then we'll see that the start step is running. This means it's the first run, essentially. Then the eat step, then the end step, and it's successfully done. And we'll see on the right. So if you're able to do this, you just executed the workflow, right? And if you look closely, you can see the correspondence between the code on the left, the output in the terminal, and here that we have a start step, an eat step, and an end step. So all this is the graph we're talking about. We've just orchestrated this graph in code and then executed it using Metaflow as such, okay? And what I want us to do now is to look at the UI here. You can copy and paste this URL, or you can go here and click on this, and this will open the Metaflow UI. So here we see we've run our first flow, which is hello flow. Click on that, and we have our progress bars essentially. So we have the start step, eat step, end step. Very cool. You can click on DAG, start, eat, end. There are lots of different things there. And what we'll see here is nothing at the moment, but when you start creating custom visualizations, we can actually have cards which tell us a lot of things about what's happening in our models. Anything you want, essentially, you can build your own cards. So but without further ado, let's go to the next one. And instead of writing Python name of flow run in the command line, I'm actually going to do this here. We also, I don't know whether someone has asked this, but we get a common question. So we're doing this all in the sandbox because we're about to access Kubernetes clusters and that type of stuff. We've had this UI, so this is how we've set it up for you. If you want to set up similar things for yourself locally or at home or at work, Eddie, would you mind just linking to the engineering docs so that people can get a sense of how to do this? Now, to be clear, it isn't like you or I can just set up this stuff in an hour, right? There's a huge amount of infrastructure that goes into this type of stuff, but Eddie will provide resources that if you want to take this to work or do this yourself and have fun doing it, you can. So let's have a look what we've run here. So you might notice that there's not a big difference between code we've run before and this code, except the start step, we're actually passing 2 new steps to it here, okay? So the self.next, we're telling it the next steps are eat and drink. Then we define eat, then we define drink, and we're telling both of them that the next step will be self.join. And that's exactly what we see here. Now, you may say, why would you do this? And I say, well, if they're independent steps, it helps in terms of time, essentially, to parallelize it, right? And what we'll see here is that, you know, each of these steps, we slept for 10 seconds, and we'll see that in total, it actually took 12 seconds. And the couple of extra seconds it took, because we needed to start and finish individual tasks, which Metaflow executes as separate processes. And if you want to, verify that this is actually what's happening, you can change these yourself and see. But let's just go back to our Metaflow UI and see, yeah, these things have happened in parallel, exactly as just stated. And in the DAG, we see that as well, okay? So now when thinking through artifacts, these are things stored from flows and versioning. As I mentioned, if we hadn't assigned 5 to an instance variable, it wouldn't be passed through steps. So now what we're doing is we're assigning it to the instance variable. And as we see here, when executed, the value of X is 6, okay? And we see that come up there. So let's just have one more look in the UI and see this. That's exactly what we thought would happen. I think once again, yep, we haven't built any cards, so things are looking okay there. But this is essentially to show you how to pass things between steps. And I know we haven't quite got to machine learning yet, but this is all in the name of setting up the basic building blocks. So when we get to machine learning, it all falls into place. So in this step, in this flow, what we're doing is we'll be doing parallel processing. So we saw how we could branch before by passing several steps to self.next. What if you have 1,000 steps though? Then you don't necessarily want to pass them all and then hand code them all, right? So what we can do to achieve that is to pass to self.next what the name of the next step will be, and then for each, and then giving it a list. So this list is 2, but we could make it 3 or 4 or however many you want. And actually, let me add another to it and see. And then in process, essentially what we're doing, maybe Eddie, you want to say a bit about what we're doing here with respect to the next step in order to get the result?
Yeah, sure. So it looks like we're taking the input from the previous step, so that this self.input variable is getting attached. And the way that is coming from Metaflow is that the for each that Hugo was just describing, they each have a unique piece of data. So we're going to make 3, in this case, process tasks. And those process tasks are coming from the self.data that we split the for each on. That's the input in the process step. And then we're going to do something on that shard of the data, if you will. So in this case, it looks like we're just assigning it to self.fruit, getting the length, and then that's our score.
Super cool. Thanks, Eddie. And you'll see how reactive our GUI is here. Sorry, our card that we're able to, I changed it and it told me about the blueberry process happening there. So I'm gonna click run on the next flow because it will take a second because we're scaling to the cloud, and then take us back to the Metaflow UI. And we'll have a look at the scale. That's the flow happening now. The for each flow. And we'll see, yeah, these are the 3. So, your apple, orange, and blueberry, right? So going back here, let's just have a look what's happening differently here. So we have apple, orange, and watermelon. We're doing for each. We're doing the same thing. And then the process step is similar, or the same actually. But if this process step is going to take significant computation, we send it to the cloud. As I mentioned previously, what you need to do is add the @Kubernetes decorator to it, okay? And that's essentially all we've done there. And then we're joining, and then we've got our end step. So we can see these tasks are starting now. So there is some time debt in terms of like startup time now for these. So the developer time is reduced a lot, but as with all cloud infrastructure, we require startup time up there. So once again, don't think that because develop time is reduced, this is something you should leverage all the time, but only when necessary, right? So let's just go back to our UI while that flow's running, and we can see, yep, the processes happen in parallel. We have these memory hog steps, which you can, we haven't done this because it'll take more time, but you can uncomment them in order to, do more computation, essentially. And it looks like we've ended now, and we just had a look in the UI. Why don't we have a look at the DAG as well? Yep, and we'll see, because we've parallelized over several things, it kind of puts the cards on top of each other to suggest that it's parallelized as opposed to spelling them all out. And you can full screen this if you want. Now we're getting to some pretty exciting things. So we're going to do production ready environments, then machine learning in action, then deploying workflows to production and reactive machine learning. And then we're going to jump into the generative AI section of this workshop. Okay. So I'm going to run this flow, and the reason I'm doing that is because it's going to take a while to bootstrap the Conda environment. And while we're doing that, I want to tell you what we're doing. So we're starting to move more in this graduated approach to machine learning. Let's just go back here for a second to a few of the things that are happening here. So what are we doing? Well, no. We're freezing library dependencies. We're validating results as a separate step, and we're creating custom report cards. Okay. So we're adding some reporting. We're freezing dependencies. Okay. And adding some validation, right? So let's just have a look at the code. Okay. So we're looking at the New York City taxi data set, which you may recall if you've seen it. We're taking this from S3 from Parquet file, is on different days of the week, talks about start and end times of taxi trips in Manhattan, prices, tips, these types of things, right? We're going to look at it over a variety of different days. And what we're going to do here, what we're doing here is we're actually performing the visualization. So in order to specify what packages we want particular versions of particular packages, right? So what we want is we want a particular version of Data Shader for visualization. Some of our data wrangling, we want a particular version of Pandas. We want PyArrow, we want NumPy as well, okay? So then let's have a look at what we're doing. So one thing is we've seen, steps, we've seen flow specs, which is what we're subclassing to create these flows. We haven't seen parameters yet. So maybe, Eddie, you'd like to say a word or two about parameters in Metaflow.
Yeah, sure. So parameters are a way to bring data into the workflow from the command line when you run it. So if we're in this case where we're kind of manually running it like Hugo's been doing here, maybe there's a file that we want to pass in into the workflow. Maybe there's some parameter that we want to use to kind of determine how we split the data. Maybe it could even be the thing that determines how we do the for each, as Hugo was showing last time. So there's a bunch of different ways you can do it. It can be kind of an arbitrary Python object, essentially, that you can pass into the workflow. And then this becomes a superpower, as Hugo will kind of lead you towards in the remaining parts of this session at the deployment time, when these workflows, maybe we're not manually running them anymore. We want to deploy them to the cloud, and then we need to pass some new data into the flow. And we don't even know what that data is until the production system generates it.
Exactly. Thanks so much for that context, Eddie. So we're having a start step where we're doing some wrangling. Then we're having a visualize step, and we're using the @card decorator, right, in order to do this visualization. And we'll see what that looks like in our cards. Then we're doing our validation step, and then we're doing our end step. And you'll see that we're doing all these plotting steps now, right, that these are happening. We've started them all. They're plotting now, so they should be happening in parallel in the UI. Let's see. Sick. Right. Yep. We're having all these visualize steps happen in parallel. We can see our visualization is happening now, which our validation, I'm sorry. And we're wrapping up. Okay. So I want to show you the visualizations in a second. What I'm going to do is actually, we're not going to talk through so much of this. I will say that we've used @conda base to specify dependencies at a flow level. You can use @conda to specify them at a step level. And we also have an @pip, @pypi decorator, which allows you to do all this stuff using pip as well. But what I want to do before showing you the visualizations is run the next flow, just because it'll take a minute or two as well. While we look at these. So if we go to the DAG, we can see once we've got start, visualize, validate, end. If we go to tasks, right, we see we've got a lot of things happening here, including our artifacts. Now, if we go to validate, which is where we've pulled all these visualizations together, what we can see is that we've got our visualizations of taxi drop-off locations by weekday. So we have it on Sunday, Monday, Tuesday, and so on, right? Now, they may not look that different. And I suppose maybe you want to do some normalization of the heat map in order to see if there are any differences, that type of stuff. A few things you can see, though, is firstly, you can see the outline of Manhattan, right? So, and of course, actually, it isn't only Manhattan. We're having trips in Queens and Brooklyn down here as well. You can see Central Park emerged. There are very few taxi drop-offs. I mean, there are a couple of paths through here. And you can see a lot of action happening in Midtown Manhattan. It looks like there's more happening on Friday. I'm surprised that there isn't more happening a bit further downtown as well, but you know, maybe that's my bias. Okay. Anyway, the short version, the TLDR, is that we've created this visualization, but you can create any visualization you want. You can have model reporting cards. You can have accuracy plots. You can put confusion matrices, whatever you want to communicate to yourself and your stakeholders. Okay. So let's now have a look at what we're doing here. This is great. So now we're actually building a model on over 1 million data points here. So what we're trying to do is we're trying to predict. It's a fare regression flow. So predict the taxi fare based on a number of features, right? So the features we're taking out are year, day of week, hour, absolute distance, longitude of pickup, and longitude of drop-off, right? So in the start step, we're reading in our parquet and we're doing our train. We've done our train test split in terms of our parameters. Then we're setting our training data set and our test data set. Then we're instantiating and fitting a random forest in the next step. Then we're importing, doing our imports at a step level, and recognize that maybe you don't want to import pandas. Isn't a small package, right? Maybe you don't want to be importing it at every step. So we're importing this at a step level and doing our prediction. Then going through what computing our metrics, so our root mean squared error and the model one, and then the baseline one. And then we're creating a custom report, which will appear as the cards did before, right? And then we've got our end step. And we had a make random forest function we used above. And we've actually defined that below. And this is something, and our plot as well. This is something that I want to make clear, is that, as you build more complex flows, you're not going to want to include all your code in your flow, right? So you may want to put this in a utils in the end, right? Or, actually, write a small package yourself or something along those lines. We've all done it in here for pedagogical purposes. But I wonder, Eddie, I know this is kind of a whirlwind tool, but there's anything you want to add about decoupling computation logic, from business logic, or any of these things when writing flows?
Sure. I think it's a good idea in many cases. Yeah, it's often useful to kind of separate the machine learning code and the business logic and the experimentation code from the actual workflow system that's going to do things like package up environments and run them on Kubernetes compute nodes, things like this. One reason is that maybe you want to develop these kinds of things in a Jupyter notebook or some kind of workstation that's very unlike, in some ways, the automated system you want to run it on in production. So it can be useful to kind of separate that piece so you can run it independent of the workflow system and then seamlessly plug it into a system like Metaflow when you want to actually go move this from development to production. Many other things that we could say there, but I don't want to break your train of thought too much, Hugo.
Appreciate it, man. And love all that context. So now, great timing. This run has finished.
Actually, Hugo, would you mind if I interjected quickly? Lou asked an excellent set of questions, really, and I think it'd be good for everyone to hear. Would it be cool if we read it out loud?
Let's do that. I do want to say quickly, though, this is interesting. If you see, these are flows that you have not seen me run, and Eddie's actually running flows in my account for the next part of the workshop as well. That's a little teaser. I do want to get to Lou's questions. Let's just have a quick look at the figures generated to wrap up this section. We've got our create report. So we've gone down to task, go down to create report. Wait a sec. And we'll see, this is what we've seen. So the correct fare is on the x-axis, predicted fare, and then this is the line x is equal to y. So we see, it's looking not horrible for a lot of it. We have some weird bands here, which we'd want to check out. But my point isn't really to diagnose the model we built, but rather to show how you can quickly build visualizations in order to do so. So yeah, Eddie, let's get to these questions. I haven't seen them yet. Oh yeah, amazing questions. Eddie, maybe you want to ask the question and then answer it.
Yeah, sure. Does Metaflow work with Kubernetes cluster that also runs non-ML services? So very good question for many reasons. Short answer is yes. You can use any Kubernetes cluster as the compute environment to run these Metaflow tasks, where you see Hugo kind of annotating these tasks with @Kubernetes. So yeah, that's the short answer. I mean, there's obviously some reasons why maybe you would want to have multiple clusters at a large organization, but that's maybe beyond the scope of this question for now. If you're curious about that, though, we'd love to have discussions like that are much more in depth around these things on the Outerbound Slack. Some other stuff that's more on the data science layer then, is there a way to compare results between different runs with cards? Hugo, I've seen people doing this in notebooks because you can fetch all these cards in notebooks. Have you seen any other ways that people are kind of comparing different runs of the same flow to kind of like see cards in comparison like this?
Yeah, so I think notebooks is the first place to do it. And we haven't done a lot of that today, to be honest. We haven't done a lot of work with the client API, right, in this workshop. So maybe you can link to some resources there. The first thing when thinking about comparing runs is we've got a really nice client API, which allows you to either from the command line or in notebooks, quickly have a look at runs you've just done. And this is in kind of the spirit of moving between prototype and production, right? And then once you've run some models, then you want to go back to experimentation and kind of treat the models you've run kind of like data in a lot of ways, right? So you can do that in a notebook, which is the first way to do it. Once you have a robust way of doing that, then putting that in cards is really nice. So this is once again something we're not covering today, but we'd love to chat about it. And in fact, let me just I don't want to. I'm going to put this link in now. If these are the types of things we talk a lot about on our community Slack as well. So I've just included the link to our Slack in the Q&A. But if you're A/B testing models, for example, you can then look at the results of your A/B tests in notebooks, or you can go to cards and build cards that can allow you to rapidly look at them as well. So the short answer is first try it in notebooks and then move to cards. Absolutely. Now, Ross has an incredible question. Does Metaflow replace the need for both Prefect or Airflow and DVC, which is data versioning and experiment tracking? So I'll say a few things about that, but then I'll pass it over to Eddie. I would never say Metaflow replaces any of these tools. You can use them together in a lot of ways. But the way I think about it is that Airflow is something that a lot of organizations already use for data engineering. And we would not suggest you come in and start using Metaflow for that. If you're building things from the ground up, you can definitely consider using Metaflow for all of these things. But we prefer to think of you being able to interoperate with them. So Metaflow and Airflow you've always been able to do kind of bespoke integrations, right? But what I wanted to show you is that, and I'll actually share a link to this as well. And you can look into this, but we spent a lot of time with the people at Airflow actually integrating Airflow and Metaflow to make sure that when all your data engineering happens in Airflow, that then you can pass things to Metaflow in order to schedule and orchestrate everything on the machine learning side as well. So Eddie, I wonder if you want to say a bit more about this also.
Yeah, I think Hugo hit the nail on the head from my point of view. I suppose on a technical layer, technically any of these tools can run arbitrary Python code. So in some sense, it's like if you really just are looking to replace tools, any of these tools with any of the other ones, you could do it. I would say that Metaflow is more focused on the kind of data science, machine learning workflows, and just kind of running more general Python code, where Prefect and Airflow tend to focus on data engineering specific things. That's kind of what I've heard from other folks, and I'm not really an expert in Airflow or Prefect, so that's kind of where I get most of my knowledge, is just through listening to our customers and the open source community. In terms of the DVC question, I think Metaflow's versioning is doing something quite a bit different. We're more talking about versioning of workflows and versioning of the artifacts that those workflows produce, whereas DVC is more trying to bring this kind of Git-like version control to the data sets, these like large training data sets themselves. Metaflow can certainly work with a tool like DVC that's doing that, but Metaflow isn't directly handling that kind of versioning, where you might want to be like looking at like S3 bucket versioning or something over a long period of time for a huge training data set. Exactly. You could definitely build them in together, but yeah, not really direct overlap with DVC.
Thanks so much, Eddie. So in the interest of time, I want to wrap up this section, but with a very important thing. This is starting to think about how to deploy workflows, right? So so far, we've developed and tested workflows locally, run them in the cloud. But if I want to go and close my laptop, we want this to run without human supervision, right? If I want to close my laptop and make sure it's still running, then I need to deploy it, right? So Metaflow interoperates with a lot of different production schedulers. Perhaps you've used AWS step functions, right? There are lots of different ones you can do, but all of these will ensure the flow executes automatically in a highly available manner. We're deploying this to one called, it's a cloud native workflow scheduler called Argo, which is incredibly robust and works incredibly well with Kubernetes, which is one of the reasons that we're using it here. But what I've done here, you'll see, is all I've needed to do is change Python name of flow run to Python name of flow Argo workflows create. Okay, you can do that by clicking deploy flow. The only other change we're making is we're adding an @trigger decorator to the entire flow, which will specify how we're going to actually. So we've created this flow. We haven't triggered it, so it's not running yet. We've deployed it, but not triggered it. Okay, so this will tell us how we actually trigger it. And so there are lots of ways to do this. We're going to do it in two ways. I'm going to trigger it by actually, now instead of Python flow.py Argo workflows create, we can do Argo workflows trigger. And this will trigger it. And I'll, in a second, go to the Argo UI to actually show you that. So this is our little Argo logo. You can click on that to go to the Argo UI. And what we'll see here is, so these are some other ones Eddie has run that let's not worry about at the moment, but this is event triggered flow. We can see there's lots of stuff here. The two things I want you to know are the workflow templates. This is the one that this happens when we create it. You click on it, you can see all this YAML. Now, this is something Metaflow does for you. You've written the flow, it converts it into the YAML that Argo or any other scheduler will require, right? So you don't need to worry about that so much. These are the templates, and these are the actual workflows here. So let's continue, and we can see that we've actually triggered the flow, and we can see we're starting it. It will end soon because we've just got a start and an end step, okay? So essentially, once that's triggered, it's there in production, okay? And I close my laptop and it's still there. Similarly, if while it was running, I close my laptop, it'd still be there. Similarly, if I've got an inference flow, prediction flow that then, or a trained model, that I want to, a prediction flow that I'm having production, then I can set up a REST point that people can ping when I go and close my laptop and all of these types of things, right? So the other way to trigger it is because I've, got the @trigger decorator with events that I can pass to it. I can, execute this code from the command line or from a notebook in order to trigger another run. So let's do that, and we can see, these are the types of things that are happening. We have some event and maybe data uploading, right? Or being added to S3 or a data warehouse or whatever it is to trigger this flow. So what we should see is essentially another run of this flow triggered. And that's exactly what we've done. You can also use cron-like syntax in order to schedule these as essentially cron jobs, right? Which will run, at any, regular cadence or irregular cadence that you want also. Okay. So yeah, I think that's all I want to say there, because we do want to jump in, and I'd wanted maybe 45 minutes for this next session, but we'll do a kind of a whirlwind tour. We have promised to do some generative AI stuff today. Before doing that, I will say we're going to do some stuff with large language models. If you are interested in other types of generative AI models and foundation models with Metaflow and how we think about it, you can have a look at our foundation models section of our blog, where we have all types of LLM stuff. We have all types of speech to text, and then stable diffusion. And actually, if you join us on Slack in the next few days, we're going to publish our work that we're doing on stable video diffusion, which Eddie and I are having a huge amount of fun with, aren't we, Eddie?
Oh yeah.
So that's super cool. So without further ado, let's have a quick chat about full stack generative AI, and then jump into the sandbox again to check out some code. So we won't go into too many details now, but in a lot of ways, the full stack of generative AI, the stack doesn't change so much compared to machine learning, except it kind of gets squeezed in or pinched, let's say, that people even care more about modeling now because they want to generate value using the models ASAP with these incredible models. But we actually require even more infrastructure. Like, you may be aware of the stuff we need at the compute layer, right? But we need a lot more sophisticated work with data, because there is a lot more data in a lot of ways. Flows are increasingly complex. when we're generating, with LLMs, unstructured text constantly, unstructured data. Well, I mean, natural language is structured in some ways, but non-tabular data, we need to think more robustly about the versioning story there as well. So we're thinking more about the types of systems we can build here, and I want to say a few words about that. Where, let's say, for example, you have a customer service chatbot, right? Where you're taking maybe a model from the Llama family, right? An open source foundation model. You're fine tuning it, generating embeddings that allow you then to build a customer service chatbot. You've got some of your own data coming in from a data warehouse there. Similarly, these LLM embeddings are feeding into personalized recommendations with stuff coming from the data warehouse that are going to another product. But the product requires image generation as well. And you're actually using a vendor API to do that, to generate the images, getting stuff from your data warehouse, sending stuff to cloud storage, then serving that into the product, right? So this is one schematic of the types of things you could be building, right? There are lots of things you want to figure out here, but one is where your governance boundary is as well. So you can govern everything you have internally here. But the open source foundation model, perhaps you don't have access to the data it was trained on, right? You only have the weights or these types of things. The AI vendor API is definitely outside your governance boundary. So you have no control over latency or certain aspects of privacy of things you're sending there and these types of things. So you really want to think about what type of risk you're taking on. Maybe, you could even be using a vendor that, may fire a CEO and then rehire him. I don't know if that would ever happen in this space at all. I mean, I'm not referring to any recent events at all, but you definitely want to think about what type of risk you're adopting when you're using getting locked into specific vendors as well, right? All jokes aside. So we're going to jump into into large language models now. The reason we've chosen this is we've assumed that everyone's kind of familiar with ChatGPT or these types of things, where essentially they're conversational interfaces. And then we're going to jump into just thinking through how we can use these to build products quickly and how Metaflow and these types of things can help you with that. So Eddie, maybe you can say a few words about generic LLMs, and then we can move on to fine tuning and then RAGs as well.
Sure thing. So this picture is essentially describing the case of using something like ChatGPT, exactly as Hugo said. We have a prompt going into the model. We have this kind of big generic model that's kind of this big blob compressing a large portion of the internet into some ability to kind of keep predicting the next token based on what it's already seen. And then that thing is eventually going to output some response. And our goal is to increase the relevance of that response. So that's kind of the whole project that we're going on for the rest of this session. And this is our baseline of just typing something into ChatGPT. The thing that we type in as a user is obviously very relevant to what we care about. And then we kind of are getting this variable relevance as the output, because the generic model is just, it's generic. It's the most general thing. It's kind of an average in some ways of the internet in a lot of ways. So then as we keep moving forward, the goal is going to be to increase the relevance of that output through some clever techniques called retrieval augmented generation. It's kind of a blanket term.
Exactly. And so the example we'll actually be doing is Metaflow documentation. So we're going to ask it, how do you specify dependencies, right? Which is something we've talked about using atconda base or atconda at a step level, right? Whereas if you went into, let's say you just wanted to ask ChatGPT, how do I specify dependencies for a flow or something? It'll probably tell you something general about conda or maybe virtual environments or pip, without being specific to Metaflow. So when we're thinking about documentation and conversational interfaces for getting information around our open source framework, this is actually incredibly quote unquote relevant. So that's what we'll be doing now. So what's one way to approach this, Eddie?
Yeah, I think the most common way that people approach it with, and the best way to get started, in my opinion, is prompt engineering, is kind of the blanket term. Which is essentially just including more relevant information in the prompt itself. So kind of the same model, we're not changing anything about the interface, we're not changing anything about the prompt beyond just structuring it in a more useful way. The way I think of this is kind of like how there's ways that you can interact with Google search as well, where you just type things into the command line in a certain way that makes Google more likely to kind of surface the sort of results that you're looking for. Same thing exists with these large language models, both in positive and negative ways, by the way. There's like a lot of security issues with the negative ways that people are doing this around like jailbreaks and things. But the core idea here is just like more relevant information in the input that we show to the LLM can improve the relevance as like a baseline idea to keep improving on.
But today we'll be going through an example of retrieval augmented generation, right?
Exactly. So similar to the prompt engineering case, some people might even consider this sort of a special case of prompt engineering. The RAG, retrieval augmented generation, what we're doing is taking the prompt from the user and say matching it against some similar inputs. And we'll talk about what I mean by similar in great detail for the rest of this presentation. And then using those similar inputs that are in a database that we consider, like that Hugo and I say consider factual data as app designers or kind of people governing the product that's using this system. Those relevant kind of factual responses from the context database are then going to increase the prompt even more. Increase the relevance of the prompt even more, and then ideally keep kind of boosting the ultimate relevance of this end-to-end generation pipeline.
Exactly. So as Eddie said, we're going to help the model by adding relevant information. But how should we find the relevant information in the first place? So Eddie, maybe you can tell us a bit about the type of vectors we're creating, and then we can jump in and have a look.
Yeah, so super quick, we can just kind of imagine, I mean, the LLMs themselves are basically just like massive pools of compressed information from web pages in large part. So you can imagine a bunch of documents like web pages or pages in a book or pages from the Metaflow documentation, which we'll show later. You can embed these things through some mathematical function and convert each of the documents to a vector. Very common in machine learning. It's like not a new concept at all. And then at runtime or the inference time, we can do the same exact thing with the user's query or some kind of post-processed version of it, and we can get a new vector. And then we can run a search process, some similarity search through something like a cosine similarity or any way to compare two vectors together. And then we can use that to produce some list of relevant results in the third step at the bottom of this picture.
Awesome.
Yeah, so we can get more into like how that interacts with the app and stuff, but yeah, I think let's jump into the code, Hugo.
Further ado, let's jump in. And Eddie, do you want to? So we're going to jump into the sandbox again. It's going to be a different instance of the sandbox. Let me see. So firstly, we do have a blog post on these types of things, and it's more comprehensive than what we'll cover here. We don't have time to cover everything in this, but this kind of we'll be going through the retrieval augmented generation stuff here, but this goes through, commercial APIs, prompt engineering, fine tuning. But we'll be going through RAGs and then building RAG systems using Metaflow. So I'm going to open my new workspace. What I'm going to get you to do now, I do not suggest you code along here. Because we have around 15 minutes left, we're going to kind of go through the code. I won't be executing it. It takes more time. This is a repository for a workshop we gave recently in Austin. And you can set up your sandbox to using these setup instructions in order to have access to everything that I'm doing here as well. Right? And this is what it should look like. But for example, the setup you have to do in Notebook 1 may take 5 minutes or so, right? So in the interest of time, we're going to jump right down to RAG and vector databases. And we have everything there. That's fantastic. So we're going to go through this relatively quickly, just to give you a sense of how this all works. And, an exercise for you later is to jump in and play around with it a lot with your self. But so the question is, and then we're going to show how to use Metaflow and Argo to deploy it. Question is, how can we use your own unstructured data like blog posts, documentation, and video collections to inform large language models. So we've got all this data. We want to chunk it, put it into chunks, right? Then compute embeddings on the chunks using a model. So put it in some high dimensional vector space. Then we want to index them in some way so they're retrievable. Can use vector databases or things like this, whatever it is. Then based on user queries, so let's say ask a question about Metaflow, I want to have a look at similarity searches on this query against the embeddings. And Eddie mentioned we can use something like cosine similarity. If you haven't heard of that before, it's essentially you've got two vectors, like if you can see my video pointing like this and some angle between them. Cosine similarity is the cosine of that angle, essentially, or some normalized version of it. So if they're closer, it's larger. If they're further away, it's smaller. Okay, so that's generally how we're thinking about things here. Then we'll return the top k most similar vectors and then decode the vectors into the original data format. Right, so this is a high-level overview of what we're doing here, but let's jump in and see how this actually works. Okay, so we need to chunk the data and upload the embedded chunks into vector storage. Now, in order to kind of give you kind of a bit of knowledge around production tools here, and one of the big challenges in this space is latency, so we want to get things as quickly as possible. We thought to mention a variety of open source and commercial solutions here. So there are a bunch here. We're going to jump in and use Pinecone to guide our example in this notebook. You install your dependencies here. We've got a Pinecone API key and an OpenAI key. I've put these in the notebook for demo purposes. Do not put keys directly in notebooks ever, or maybe just when you're working by yourself, but it's really easy to forget that. You want to use environment variables for the most part, or something like Metaflow secrets, which Eddie may link to if he has it up, which allows you to safely and securely store all your types of secrets, including keys. Then what we're doing here is we're uploading the index, okay, and then we're doing a toy example here. We're taking 3 text samples, which we will then compare to questions around Metaflow, right? So, hello, Gen AI friends. Metaflow helps you build production ML workflows. Then lots of people recognize ML systems require robust workflows. And you may expect that when we have a look at Metaflow queries against these samples, that the cos similarity should be pretty high for this, then maybe a bit less for this, then a bit less, but still positive, potentially, still correlated with that one, okay? So then how do we think about embedding these? And I appreciate we're moving quite quickly here and that there's perhaps an impedance mismatch between the sophistication or the complexity of the earlier onboarding lesson we did with in the sandbox. But the intention here is to show you more production stuff to wrap up this class as well. So you have a lot more to work with. And anything you want to find out more about this, please do come and join us on Slack as well. So what we're doing here is we're taking a transformer model from Hugging Face in order to embed these text samples in vector embeddings in high dimensional space. Then we're going to create our Pinecone index. Then we're going to upsert, which is a common term for essentially inserting our text sample embeddings into the database. Is that the best way to explain upsert, Eddie?
Yeah, it's similar to an insert operation. Minor difference, but not a big deal.
And then we're doing our query. What does Metaflow do? And then we're going to compare it to the top 3. And Eddie, if I execute matches now, should I be able to see?
Yeah, I think so. Looks like you still, use the PyData one there. Oh, it looks like the cells would need to get re-executed again. So since we only have 10 minutes, maybe it's not the best use to rerun everything above.
So what you'll see here, everyone, when you run this is that the matches actually, because it will take too much time. The matches, you'll see that, as I said, what does Metaflow do? We'll have a relatively high cosine similarity to this, slightly lower for this one, and then slightly lower for that one. Is that correct, Eddie?
Yeah, that should be right. Yeah.
Yep.
Sorry about that. Maybe the next. No, yeah, there's
Not at
nothing
all.
there. Okay.
Great. So this was a toy example, right? But now we want to kind of upload all the Metaflow documentation to be able to query it, right? So what we're doing is we're going to take this repository path, which is the Metaflow docs under the Netflix's repo. We're going to take everything in there and convert it into a data frame and do a bit of filtering. And then we'll just have a look at the data frame and we'll see we have headers, we have contents, which is some form of HTML. Then we have the page URL, character count, word count, a few other things, right? So as we previously did, we're going to create these embeddings, right? We're going to see the dimension is 384. Then we're going to create our index, and then we're going to upsert everything in there, okay? Now we've done that, we want to then use this RAG system with our with a generic LLM such as ChatGPT in order to see whether it helps us answer our question. Now, how do we know if it's going to help us answer our question? We need some form of benchmark. So this is what I mentioned before. What we're doing is we're going to ask ChatGPT essentially the query that we defined here. How do I specify conda dependencies in my flow? We're not mentioning Metaflow. And as I said before, yeah, so ChatGPT is saying to specify conda dependencies in your flow, you create an env.yaml, and then you do yada, 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 okay? And it actually, this is cool. It gives a prefect example as part 4, right? But this doesn't answer our question. And nor should it answer our question, right? Because we haven't added our documentation to it yet. So let's now actually do that. So remember we talked about how many things from our RAG, from our documents we want to retrieve. We're going to choose 5, and this is a design choice, and this you should really think about how many you choose when you're designing your application. But we're going to choose 5 for the time being. And so we're going to embed and match our search vector. Let's look at the 5 that were retrieved, and we see its compatibility with Conda, PyPI, Conda decorator is great, Conda base, treeing across branches, disabling environments. That looks pretty good to me. So now what we're going to do is add these using RAG to ChatGPT using the OpenAI API. So we're giving a system message saying you're a helpful assistant. That helps us with Metaflow, essentially. And then we're adding in our user query. And I won't go into all the LangChain and OpenAI stuff we're doing here. But essentially, we're using RAG now to bring in these documents in order to answer this question. And what we see when we convert it to Markdown is to specify conda dependencies in your Metaflow flow, you can use the @conda decorator. The decorator allows you to make specific packages available to Metaflow steps. And exactly. So we see, and it's the example here, it has different dependencies for each step. So we've got NumPy here, we've got pandas there, which is a nice example. Okay. So we've got 6 minutes left. And I know this is some real 11th hour stuff and we're pushing up against it, but this has been a whirlwind introduction to retrieval augmented generation. The reason we wanted to do all of that is then show how you can put these in production pipelines using Metaflow and a scheduler such as Argo. So to do that, let me actually, oh, this is annoying. I don't have a slide on that for some reason. Okay, in our blog post, I meant to add this slide to there, where essentially going to have 3 flows which will trigger each other. We have our markdown chunker, which is the chunking of all the documentation. Then the data table processor, which processes everything. And once that's done, we're going to do the vector indexer, which then can be used for the RAG stuff, right? So we're going to have all of these scheduled on Argo to trigger each other. Okay. So, whoa. Let's just. So in the interest of time, I'm not going to write the command line, but we can see when I click deploy, and we can see this is scheduled weekly. I clicked deploy, Eddie, and my terminal went blank.
Could be a network situation. Not sure about. Yeah, maybe a refresh. The workflows are already deployed, Hugo. So maybe if you just want to like type out the trigger command, it could work quickly.
I do. I do want to show people how to. So.
Yeah. So this one will just be the Python Argo workflows create then.
Exactly. So we're in 4 mission FlowPy Argo workflows create. And we'll see we've scheduled this weekly, but we're actually going to trigger it ourselves today. Great. And we'll see that in the Argo UI in a second. The next one, which is the post-processing workflow, we'll see that in order to make sure that it's triggered when the markdown chunker finishes, all we need to do is add the @trigger on finish decorator there. So that's essentially what we're doing here. And the point to say is that's the only difference to doing things locally and deploying things. So that's in the interest of making this tool as human-centric as possible. And closing the iterative loop between prototype and production. So we're deploying this one. And it says, look at this beautiful output. This workflow triggers automatically when the upstream markdown chunker flow succeeds. And we're going to do the same here. Python 06 flow.py Argo workflows. Great. Great. And I'm going to go, I love it. We've got 2 minutes left. I'm going to go into the Argo UI. And yep, we'll see our markdown chunker, data table processor. Eddie had created these some time ago, so that's why they were created at that point. None of them, this has been triggered some time ago, but not recently. So we're going to trigger this now. So remember, the only thing I need to change here, Python 4-section FlowPy Argo workflows. Trigger. And we should see that appear here in a second. Great. So we see the markdown chunker has started. Well, it's about to start. Now, we've got 1 minute left. I'm very happy to answer any questions. And if you need to go, please do. But what we should see, if you stick around 1 or 2 minutes, what you should see is that it will trigger the post-processing flow. We may not have time to stick around to see it trigger the Pinecone vector indexing workflow, but all of this sandbox is available for you in perpetuity. So feel free to play around with it yourself and come and chat with us in Slack as well. While this is running, Eddie, so let's see if there are any questions. Someone said thank you for the very interesting workshop. Such a pleasure, Anna. Eddie, while this is, we can see the start step started. This is good. Is there anything you wanted to say?
No, just thanks for everybody for all the great questions and for the attention. It was really fun presenting at PyData today, and hope to see more of you in the Outerbound Slack and keep the conversation going. Let us know also if you have requests for more content like this in the future. Hugo and I are always looking
Absolutely.
for more stuff to present like this to our audience.
And as we said, come and join us on Slack. I'm at Hugo. Eddie's at Eddie. You can DM us. But any questions you have, specific questions, ask them in public as well on Slack, because a lot of other people love to jump in. We've got over 3,000 data scientists and ML engineers who love chatting about this type of stuff as well. So look, we're nearly there. We're 1 minute over, and this should end in a second, and we'll see the next one triggered and start.
I don't know if it's just on my side, Hugo, if it's just my internet, but there's like just enough of a lag on the spinning wheel. It's just giving me the spinning wheel of death feel from the MacBook, kind of
Absolutely.
just on
Yeah,
the last minute of the tutorial. We're almost there.
that's right. And, okay.
Oh, there we
Moment of
go.
truth. Yes. Okay. So data table processor is starting now. So we've seen one flow trigger another, which is super cool. And actually, if you want to I think maybe Metaflow 2.9 is what we called it. Yeah, if you want to find out more about the event triggering, this was a highly requested feature that a lot of people are finding value from. Thinking about, event triggering. This is a figure we showed before. When data is updated, can trigger a flow. Similarly, flows are flows. So when you have a training or flow, it can then trigger an inference flow. But essentially, what we've seen is one flow trigger another. Were we to stick around longer, we'd see this trigger the final flow to build our RAG production system. Whoa, great. Just a sec. The end step. Look, if anyone wants to stick around 20 more seconds, we should be good for absolute completeness to see this work. It looks like a whole bunch of people are still here. I'm so happy that you're sticking around. I very much appreciate you for doing so. And Eddie, we've gone to the Argo UI to have a look at all of this stuff. But correct me if I'm wrong, but a lot of these things will be available in the Metaflow UI at some point as well. Is that correct?
That's correct. Yeah. So, I mean, in one sense, they're already available. So if you want to go to the Metaflow UI right now, we can see it. But yeah, eventually Metaflow is going to kind of become a superset of the Argo UI itself.
So
In the next
this is great.
month
What
or
we've
two.
seen is now the compute intensive step has started, but we saw Markdown Chunker trigger data table processor, which ended, which has now triggered Pinecone vectorizer indexer. Super exciting, which essentially means we've been able to build our live production system with RAG in order to do this. And I think that's a wonderful note to wrap up on. Really appreciate you all joining. I understand we've covered a huge amount in 90 minutes. I mean, this could be a day-long, if not a week-long workshop. But we wanted to make sure you had enough things to really go and get started and jump in and choose what you want to use and not. So appreciate you sticking around a few minutes longer. And with that, we'll wrap up, and happy to answer any questions in Slack or anything along those lines as well. So thank you for joining, and thanks once again to PyData and Jim for having us here.